Welcome, everyone. Today, we're diving into the essentials of understanding your data before writing advanced queries. On this first slide, we'll explore the key concepts of examining all columns, understanding the structure of your data, and preparing for effective queries. We'll also look at a simple example, select from table name, to illustrate how to start exploring your data. This presentation will guide you through the important steps to become more confident with your data analysis. Let's get started. Let's take a closer look at understanding data in SQL. When we talk about data, we often see examples like email, phone, last name, first name, and ArtistId. These are all columns in a table. And when we want to see all the data in a table, we use a simple but powerful command, select from customers. This command returns all rows and all columns from the customers table. Think of it as asking, show me the whole table. Every row, every column, nothing left out. The asterisk or the star symbol is just a shorthand that means all columns. So when you see select, it's telling the database, give me everything. It's important to understand the table structure first, seeing what columns exist and what data types they hold, because that helps us understand what data we're working with. Using select is a quick way to see all that data at once, which is very useful when you're just starting to explore a new table or need a broad overview. Now, let's take a closer look at some key concepts related to understanding data within a database. On this slide, we see examples of employee and customer tables. For the employees table, you'll notice columns like ArtistId, first name, last name, title, and others. These columns represent different pieces of information we store about each employee. Similarly, the customers table includes columns like ArtistId, first name, last name, email, and so on. When we write a simple SQL query like select from employees, it tells the database to retrieve all columns and all records from the employees table. The same applies to the customers table with select from customers. This highlights an important point. These tables are real-world examples, and understanding their structure helps us organize and retrieve data effectively. Recognizing the columns and their purpose is fundamental to working with databases, especially when we start writing queries to find specific information. Connecting this to the overall theme, understanding how data is stored in these tables sets the foundation for more advanced operations and analysis later on. Let's take a closer look at understanding data within our SQL concepts. Here, we see that the ArtistId acts as a key link between the albums table and the artists table. This is really important because it's how joins will work later on, connecting data across tables based on shared identifiers. For example, if we look at the columns in the artists table, we see there's a name and an ArtistId. Similarly, the albums table has albumid, ArtistId, and title. When we perform a join, SQL uses the ArtistId to match records from both tables, allowing us to combine related information seamlessly. Think of it like a puzzle. ArtistId is the connector piece that fits into both tables. This way, we can easily retrieve all albums by a particular artist or see which artist created a specific album. Remember, understanding how these tables connect through keys like ArtistId is fundamental to working efficiently with relational databases. It sets the foundation for more complex queries and data analysis later on. Let's take a closer look at understanding data within our SQL concepts. Here, we see different types of data we might encounter in a music tracks table. For example, the cost to purchase a track, which is represented as unit price, gives us a monetary value. File size, measured in bytes, tells us how much storage space the track requires. The duration of a track in milliseconds indicates how long the song plays. We also record who wrote the track, which we store as the composer, and the music genre, identified by genreid. The format type, such as MP3, helps us understand the file format, linked via MediaTypid. Additionally, links to the albums table are made through albumid, establishing relationships between tracks and albums. The track title, simply called name, provides the song's name, and each track has a unique identifier called trackid, which is essential for distinguishing each record. To see all this information together, we can run a simple SQL query, select from tracks. This command retrieves all data related to music tracks, giving us a comprehensive view of our dataset. Understanding these data points is fundamental because it helps us organize, analyze, and make decisions based on the music library data. It all ties back to the overall theme of how we structure and interpret data within a database. Let's take a closer look at what we mean by understanding data in SQL. On this slide, you can see some example products we've added, like water bottles, backpacks, pens, and notebooks. For each product, we've recorded details such as the name, price, and stock quantity. For instance, the water bottle costs 120, and there are 90 in stock. Similarly, the backpack is priced at 450.5 with 40 units available. These details are stored in a table called products, which we can view using the command select from products. This command fetches all the data from the table, giving us a complete picture of our products. Apart from that, you also see some custom data that you've inserted yourself, like customer names and their cities. For example, Nasik has 9 customers, Rohan has 12, and so on. We also have a separate table for students, with details like age, city, grade, and ID. The command select from students helps us retrieve all that student data. The key takeaway here is understanding how data is organized in tables. Each table holds related information, and SQL commands allow us to retrieve and work with that data efficiently. This foundational knowledge helps us manage and analyze data effectively, which is central to everything we do with databases. Always remember to explore your tables first. Understanding your data is the foundation of creating great queries. For example, take a look at the products table, which includes ArtistId, name, price, and stock. Or consider the students table with name, id, grade, city, and age. Each table gives you valuable information about the data it holds. Similarly, the tracks table contains trackid, name, albumid, genreid, composer, and unit price. The artists table has ArtistId and name, while the albums table includes albumid, title, and ArtistId. Don't forget the employees table, which includes employeeid, title, hire date, and reports to, or the customers table with customerid, first name, last name, email, and phone. The key point here is to always start with a simple query like select from table name. This is your first step when working with any new dataset. It helps you get an overall view of the data structure and the kind of information stored there. By taking this approach, you'll gain a clearer understanding of your tables before diving into more complex queries. And when you know your data well, crafting effective SQL statements becomes much easier. So always take the time to explore your tables first. It's a crucial part of the data analysis process.